Okay, everyone. Thanks so much for coming out for a little affairs. Yep, you've heard that. We're going to do something here. So we're changing over to the categorical binary independent variables. So we have gender here, right? This is already attached, etc. So female, male. Then you come over here, we have NBAs. And that's not NBA All-Stars. That is affairs. So most say no. So you know they're lying. But a lot say yes. Look at some of these affairs, 7, 12. That's a lot. So we're going to use two variables here, gender and affairs. See if there is a difference. So when you start looking at it, these are categorical binary, meaning only two independent variables. That's why anytime I teach a course on statistics, I begin, although I don't test, the different types of variables. So you have quantitative variables like the dosages and the survival of the mice, like the year and the area of ice, or like obviously ice cream, right? Temperature and consumption. So this is very, very interesting. We're going to run some stuff on this. But first, quick couple things. You can easily do this first to see, okay, how many women do we have and how many men do we have? So you just run it. And it says female, 315, male, 286. If you want to know the amount of affairs they're having, you can use the Tapley. See, table is pretty easy, right? It's just a table function and then affairs, gender, this. But if you look at it, I won't run it. I'll show you how to do it. Tapley, right? That's just a base, right? So you put affairs, that's the name of the data set, see? And then to keep the dollar afloat, you just hit the dollar and all the variables come up. So you got to do the number first. So that's the number of affairs. And then you do the same thing over here. Ba-boom. Keep the dollar up. You hit the dollar sign and all the variables go up. So we're interested in gender. Got to do it in that. And then the function is the sum. So what you see here is to do, and then we're going to do sum. So we have females, of course, they're cheating on the men. I think people lie in these data sets anyways, but it's pretty interesting how we can still use the LM function, even though we're dealing with categorical, in this case, binary. Remember, it doesn't have to be binary. It could be different things like, when we talk about other things like class, could class, first class, second class, third class, although I don't like that word. That would be then not binary, but there would be 3 categorical variables and you can still use the LM function. So let's see what's going on here. So let's call it something. So this is the data set. And we're just going to go over here and do the typical thing. So we'll call it cheating. Yay, cheating. And you call it cheating, LM function. Remember, dependent variable first, which is number of affairs. That's not MBAs, like NBA All-Stars they're not having affairs with. And then the independent variable, which again is it's sometimes sex or gender. In this case, it's gender. Yay. And then you can put the data equals affairs. Boom, boom. So same setup as before. So this isn't that difficult. So but I just want to stress that we're using binary categorical variables for the independent variable, gender. So let's take a look if there is a cheating. And I think I did it with robust as well, but we're not going to do that now. Let's take a look at the results. So this is basically, in this case, you see an intercept, which is basically the women. That's why the women are having more. And then you have the male. So the male, in this case, there's a base, unlike with quantitative variables where they're just associated the variables like temperature and consumption. So in this case, we're using a base, but it's still the same thing. Look at standard error, t-value. The bigger this t-value, that's a very low t-value. Obviously it's not significant. So that means there's no, we went over the p-value and all this other stuff. There is no real significance between men and women having affairs. But as the table showed us, Tapley, that women are having more affairs. That's just an easy way to do it. So let's take a look at something here like I've been showing. Like this just works as a calculator. This is why the p-value and standard error are very important. Right? And that's why we're getting somewhat around that number, which is very low. So we're basically this t-value, the standard error. Oh, sorry, my mistake. I'm gonna go boom. I did the number 46 divided by the standard error. Remember, this is the base here. So we're gonna take a look to see if there's any. 287. See, that's why our t-value is so small. We have a very small increase in comparison to women. So, that's our practical value, although we're going to be using it as a base. And we're going to see that more when we get into more categorical variables when we do the gorilla data set, that is the Colombian Civil War. So as you can see, the p-value is 0.774. It's not below 0.05, which is common, as I've gone over ad nauseum, in the social sciences for significance. It's a very low t-value. The multiple squared is, well, let's just face it, pathetic. And you got a pretty big residual standard error there on 600 degrees of freedom. Remember, that's minus the two variables, independent and dependent. So as a result, what we have here is a very poor model, showing that there is no significance. Now, when I say poor, I'm just saying there's no significance. It doesn't mean that this doesn't have practical value. This is essentially saying, based on the data we have, there is no quote unquote statistical significance between men and women having affairs. And even more importantly, the goal here is also to show that we can use categorical binary independent variables and still use the LM function. And then we learned a couple other things. If you just want basic information, we got the table, affairs and gender, and then Tapley gives us how many affairs are having. So you can see women, according to this, although I think the men are lying, are having more affairs, generally speaking. And again, because it's 0.0, it's not below 0.05, it is not statistically significant. When it gets below 0.05, that means that it's not happening, basically, without the independent variable. That's why we can consider it significant. And usually this decreases the residual standard error, although they are different measurements, and we usually get a better multiple R squared. Remember the multiple R squared, because it can't be a perfect one because it's squared, but regardless, just say the perfect R squared is 1. I mean, that's very far away, 0.0001377. So thanks everyone for coming out. That was a quick short video on showing how to do regression, even though we have binary categorical independent variables. So take care, everyone, and thanks always for coming out.